All right, so for this video, I'm going to talk about polynomials. But before I get into it, we need to know how exponents work and the properties involved with it. So I'm just going to list out all the different properties, and it is kind of a lengthy list, but trust me, once you know the rules, you don't even think about them. So starting out with the most basic, x to the power 0 is 1. X to the power 1 is x. X to the a power times x to the b power is the same thing as adding the exponents. So notice this only works when you have the same base. So if it was like x to the a times y to the b, that wouldn't work. So just kind of be mindful of that. And then if they're being divided, x to the a by x to the b, it's the same thing as subtracting the exponents. You have x to the a to the b power is the same as a multiplied by b. So power over power, you multiply them. If they're side by side like this, being multiplied, you add them. Let's see what else. So x to the y, x times y, and it's all to the a power. This is a distributive property where the a will be distributed to both the x and the y. So you'd have x to the a, y to the a. X divided by y. This is to the power of a. Again, just showing the distributive rule, but if it was like in a fraction, same deal applies. You distribute that to all your variables. If you have x to the negative a, so I know this is something that's a bit challenging to grasp in the beginning, but this is actually just a reciprocal. You can write it as 1 over x to the a. And I don't think this will be touched on in this video, but I figured I just would bring it up. X to the 1 over a is the same thing as saying a root of x. So for example, x to the 1/2 is the exact same thing as saying square root. But again, I don't think this is going to be quite brought up yet until the radical video that I will make. But these are all the properties and rules for exponents. Okay, so moving forward, I'll just go through examples here and just showing you how to simplify expressions. So let's see what we have. So for example, if you have like -5/8 to the 0, according to my properties, this is the same thing as just saying 1. So literally anything to the power of 0 is just 1. It could be, you know, a very like long, like huge number, right? But it would still be 1 if it's to the power of 0. And likewise, you know, anything to the power of 1 is of itself. So like if I had 1052 to the power of 1, that's just 1052. Let's see what else. So if I had 3 to the -2, so again, just be careful. This doesn't mean that my number is negative. It actually just means it's just a reciprocal. So 1 over 3 squared, which you can simplify down to 1/9. So if we did that for like 10 to the -3, same idea, 1 over 10/3. I think that's just 1 over 1,000. And just same idea, like if you had x to the -5, that's 1 over x to the 5th. So, and I guess another example I could talk about is what if you had a negative exponent in the denominator? Well, that's actually pretty easy. Kind of like how when we have a negative exponent, we move it to the denominator. Well, if we see it in the denominator, it actually becomes positive up on the numerator. So that's a really neat thing to notice, that if it's a negative exponent at the bottom, you can just move it up top and make it positive. So likewise, if I had 1 over 2 to the negative 5, it's the same thing as saying 2 to the 5th. Okay, let's do some other type of examples. If I had 6n to the negative 5, right? So again, we can kind of think of this as saying, oh, 6 times 1 over n to the 5, right? So then you could just say 6 over n to the 5, like that. And let's just do another problem that's pretty similar. So x, y to negative 2. So that negative 2 is only being applied to the y. So I just have x times 1 over y squared. And so I have just x over y squared. Okay. So let's try some other problems. So if I had 2 to the 4th times 2 to the 3rd, of course you could go ahead and solve these and multiply, but I just want to show you how the exponent properties work in this case. So because they have the same base and they're being multiplied, I add them. So it's going to be 2 to the 4 plus 3, which is just 2 to the 7th. So if I had n third times n 20, I get n to the 23rd. If I had t0 times t16, of course that's just t16. If I had 2t to the 8th and then 2t to the 17th, again, same idea. I can just say, oh, just 2t to the 25th power. Okay, so what if one of them is negative? Still no problem, just add them. So negative 8 plus 9 is just 1. So I just get 5 to 1 power, or you can just say 5. Okay, and then most likely on the exam for the TSI, you might see it more in this form. But again, don't let this confuse you. Just follow the same rules. So you just kind of match them up. So look at the s's. So we have s squared and s1. So you just add them. So you have s to 3. Same thing, look at the t's. And you just add them at the exponents. So that's t to the 7th. And remember, this only works because they're being multiplied. So that's something that you need to be mindful about, and we'll kind of discuss later on in this video. So let's do another one similar to the previous one, where we have m to the 4th n, m squared, n to the 7th. So here I have m to the 6 because 4 plus 2 gives me 6. And for n, again, that's a 1 there. So we have 1 plus 7, which is 8. Okay. So what about if they're being divided? So for example, if I had y to the 9th over y, it's just 9 minus 1. So that's just y to the 8th. M to the 6 over m to the 12th. So that's 6 minus 12. And if it helps, if you get kind of tripped up sometimes, it doesn't hurt to write it out. So I have m to the negative 6, which since from what we learned previously, just now about negative exponents, I can write this as 1 over m to the 6. Similarly, if I had 8t to the 4th over 8t to the 11th being divided, this is 8t, so 4 minus 11 would give me negative 7, which again I can write as 1 over 8t to the 7th. Okay. And let's try some with negative exponents. And no need to fear about negative exponents. We know already how to work with them, so we're just gonna take it piece by piece. So here I'm gonna do the subtraction. And again, I think it'd be helpful to write it out just in case. That way you're not, accidentally doing -9 and just simply -3. As we can see here, we are subtracting a -3. So we have -9 plus 3, which is x to the -6, which is just 1 over x to 6. All right. And perhaps maybe we have the form of a to the 5 b cubed over a squared b. So again, just take it piece by piece. So looking at the a's, that's 5 minus 2, which is a cubed. B is 3 minus 1, so that's b squared. Likewise, another problem that I have, s to the 8 t to the 4th over st cubed. So this is the same as s to the 7th, and then just t. Okay, so now let's do some other examples, specifically talking about the power rule, which is like x to the a to the b power. This is equivalent to a times b. So for example, if I had 3/5 to the 4th power, this is the same thing as saying 3 to the 20th power. Or if I had y to the -5, and then to the power of 7, this is y to the -35. And again, I'm going to write this as a positive exponent, so that's 1 over y to the 35ths. And it just kind of keeps going. If just showing you these examples, so a to the -4 to the -6 power is the same thing as a to the 24th. And then here I have x to the 4th to -2, which is x to the -8. All right. So that's the power rule here. I guess I should write that there. And then another of the rules that I mentioned earlier was, if we had a power and we had multiple things kind of like inside. So in this case, if they're being multiplied, this is the same thing as saying x to the 8th, y to the 8th, sorry, x to the a times y to the a. So you can see that I just distributed the a onto each variable. So for 4x squared to third, this is the same thing as 4 cubed and then x to the 6. Yeah, sorry, I got distracted for a bit. So for the second example I have is if I had 5x to third, y to the 5th, z squared, and to the 4th. This is the same thing as saying 5 to the 4th, x to the 12th, y to the 20th, and then z to the 8th. So you can see, again, I'm just multiplying this exponent onto everything and including that 5. So it doesn't have to be x's and y's. It can also be to the coefficient. So don't forget about that. Okay, so let's try -5 x to the 4th, y cubed. So again, I apply this to everything. So this is going to be -5 cubed x to x to the 12th, y 9th. And I guess we could simplify this down. We would get like -125 x to the 12th and y 9th. I should mention that realistically in the TSI they might have their answer choices like actually like solved, and 4/3 is 64 x to the 6, and then for this previous one is 625, x 12th, y 20th, z 8th. I kind of doubt they would expect you to know 5/4. 5/3 might be more reasonable. But I mean, typically, I think as long as you know your squares, that's pretty good. So don't freak out too much if you don't know 5/4. It's just part of the example I had. Okay, so let's try some other examples. Perhaps we can try with more variables. So 3x to the third, y to the negative 5, z squared to the fourth power. Distribute that to each variable or coefficient. So 3 to the fourth, x to the 12th, y to the negative 20th, and z squared, or sorry, z to the 8th. Okay, so 3 to the fourth will simplify to 81 x 12th and then z 8th. Now notice I didn't put the y there, and that's because my y to negative 20 I can write in the denominator as just y to the 20 at the bottom. And likewise, for another example I have, negative 2x to negative 5, y to the fourth to negative fourth. I'm going to apply this to everything. So negative 2 to negative 4, x to 20th, and then y to the negative 16th. So here, well, first of all, I'm going to move everything that has a negative exponent at the bottom. So I'll just have negative 2 to the fourth, and then y to the 16th, and then x to the 20th. And if I wanted to simplify negative 2 to the fourth, that would just be, no, I think positive 16. Yes, okay. So that'll be the solution there. So that's the gist here with when we have a power over power. You just multiply, but you also distribute it onto everything. And now we're going to do that for if there's like a fraction inside, so like a over b, and it's to the power of n, the same thing as a to the n over b to the n. So for example, if I had x squared over 4 to the third, this is the same thing as x to the 6th and then 4 cubed. 3a to the 4th over b cubed squared is the same thing as 3 squared a to the 8th and then b to the 6th. So if you notice again, I'm distributing this power onto everything, which in turn you just multiply the exponents. So let's try another example. Y squared over 2z to negative 5 all to the power of 4. So it's the same as y to the 8th, 2 to the 4th, and z to negative 20, which I can write as y to the 8th, as z to 20 on top, and for 2 to the 4th is 16. And perhaps we can do just one more. Y cubed over 5 to negative 2 is the same as y to the negative 6 over 5 to the negative 2, which I can kind of flip-flop here and just have 5 squared over y to 6. Kind of ran out of room here, but just putting my arrow over here to show that this is equal to 25 over y to the 6.